Welcome to the advanced module of the smart car charging. This video will go into the technical details of how you can build your own feature-rich car or fleet of cars charging solution. As we saw in the introduction video, how to charge your electric car for free with solar energy, the price of transportation continues to increase globally to the point that driving a car has become over time very expensive. On the other hand, renewable energy technologies are maturing and are gaining popularity. The net result is that those technologies are increasingly affordable. Solar photovoltaic panels, for example, see a price trend showing a decrease as the price per watt-hour of energy produced by solar continuously falls as demand grows. In the previous video, we also reviewed that the International Energy Agency confirms that EVs, electric vehicles, are greener than traditional internal combustion engine cars, and through renewable energies, the opportunity to further decrease greenhouse gas by an additional 30%. Should you want more details, please review the introductory video. In this advanced video, we will today review the implementation of a smart car charging service as part of the architecture recommended in this channel. To be able to follow this video, you will need the following. First, Home Assistant installed and functional, which we will use as a foundation of the smart home grid implementation. Second, Node-RED to help us scale automation. And finally, understanding of test-driven development. If those concepts are new to you, please review the intermediate level video, How to Build Your Smart Home Grid, which will introduce those concepts and guide you step by step. You will find a copy of this video here, and also I will put it in the comment. Now, if you have it all under control, let's get started. The setup I will be using will not be unusual. I have all of the key elements needed to get started, including obviously an electric vehicle, an electric car charger, and a Home Assistant server. I also have an inverter, solar panels, and well, enough of them to support car charging efficiently. We'll come back to that in a few minutes. All those elements are fully connected to your local network and to the cloud if required. Should your car charger not be connected and therefore charging cannot be started or paused, you can easily ask your electrician to add a relay which could be activated by a smart switch through Home Assistant. Let's start with the first hurdle, getting your inverter, car and car charger integrated into Home Assistant so you can stream telemetry from them and control them as appropriate. Once successful, you should be able to have access to inverter, car and car charger telemetry and configuration as you can see in the screen. If you are relatively new to Home Assistant, you might wonder, how do I get those integrations working? Let's have a quick review of the main ways you can get your devices integrated to Home Assistant. So we must now find how to integrate car charger and inverter into Home Assistant. This is done through what is called in Home Assistant integrations. I'm on the Home Assistant website and I will now click on integration to see the integrations available. If I click on car, as we can see, if I have a BMW, a Nissan, Subaru, Renault, a Tesla or Volvo, all of it is taken care of. Click, install, add your credentials and off you go. On the same token, in case you have a car charger from the brand Wallbox, for example, or EVSE, everything will work immediately. If your car inverter or car manufacturer, car charger manufacturer is not in this list, well, you always will have to go to the community integrations. For example, if I hit Google for Home Assistant Audi community integration, well, I have a direct access to this link that gets me to the instructions on how to add Audi Connect to Home Assistant, either through the Home Assistant hacks, Home Assistant community, or manually. I could have replaced Audi with Ford, get me to the right link immediately. So in case your systems are not readily available in either in Home Assistant integrations or through community service, there are typically ways to connect your system, such as your inverters, through, for example, Modbus. Before we proceed, let's briefly review the Open Charge Point Protocol, also known as OCPP. OCPP is a protocol for communication between electric vehicles and car charging stations. It is an open standard that many car charger manufacturers have implemented today. As you can see in this screenshot, OCPP provides the same amount of control and information I had with my direct integration with my wallbox car charger. The downside is that using OCPP, I no longer would be able to leverage my car charger mobile application, as all interactions would have to be done through Home Assistant or its mobile application. So, in case there are no integrations available from either the Home Assistant core system or the Home Assistant community, this could be your best workaround. Ensure OCPP version 1.6 or above is supported and you should be good to go. Let's assume you have a basic car charger that allows you to charge your car at 3500 watts, which is where I live, 16 amperes. And that would be the case if your car charger is not connected and you can just activate a relay through Home Assistant that starts the charge. Now, first off, a small disclaimer. This tutorial assumes your home runs on 230 volts, such as we have in the EU. If your outlets run at 120 or 240 volts, you will need to adjust the math as appropriate to make it work for you. In this simplistic scenario, the algorithm is very simple. Repeat regularly the following step. First, should your car be connected to the charger and its battery not fully charged, get the current electrical consumption of your home and the solar panel's electricity production. If, after the demand of your home, you still have 16 amps available, that is 3.6 kilowatt, assuming your home runs on 230 volts outlets. Start the car charging, else pause the car. This simplistic example provides a solar car charging implementation similar to what many vendors provide for a few hundreds of dollars or euros. Let's have a look at how this could be implemented in Node-RED. So we are now on my Home Assistant home server. As you can see, I can also have access to my inverter data, home consumption data. Ignore the home batteries for now, please. And I am currently charging my car and I have access to the full telemetry of my car charger. I'm charging like 16 amperes, which is 3.6 something kilowatt. Before I go to Node-RED, please note the developer tools, where if I go to state, I have access to all of the entities which I can query. For example, if I go to my wallbox entities, I have access to all of its data through sensors. And I can program it by locking it, numbers, by injecting a number here or here, whichever I want to do. So if I go to Node-RED and I go to the fixed 16 amps car charging, we can see the logic is right there, right in front of us. Interestingly enough, you most likely noticed that most of the hard work was done on the left-hand side, which is just getting the data. Every minute, the big timer node will tell me if there is light or not where I live. If you don't know what big timer is, please review the Building the Smart Home Grid video in my channel. This node will send a 1 every minute there is daylight. In case there is not a 1 coming out of this green box here, it is night, and therefore, in case I'm still charging, pause the charger. Pausing the charger is just invoking this specific entity with an instruction turn off. Then once I know we are during the day and therefore there is sun, I will first get the car plug status, which again I do by querying a binary sensor. Is it plugged in, yes or no? In my case, this plugged in, so it's good to go, and therefore we should continue. Then I will get the car battery status. If the battery is full, why worry? So I will again get the charging status from Home Assistant, and in case the battery is full, which is this data set will be at finished fully charged, I do nothing. There's nothing coming out of this node. Same here for plugged. In case it was not plugged, I just would have stopped right there, nothing to do. Once I know there is sun, the car is plugged, the battery needs to be recharged, I go to the next step, which is to get the data from my two inverters. You most likely only will have one. So I'm going to be doing the sum between the two, which I will be doing with JSON expression and using the variables where I've captured. More on this soon, but keep in mind that I'm keeping the data into a variable called flow.sum of PVs. And I've also kept all the data before. So I get the charging status, and then I will have to do some basic math. You will notice that I've captured a lot of information and stored it in variables, which is key. So in case you don't have it yet, click on configuration notes to get this data here. Go to the context data, and this is where all of the data I've been storing myself is captured. So it is plugged through. The car battery percentage is charging. My car charger is also stating charging. I'm currently generating 5,000 watts of energy, out of which 748 are used by my house and the rest is available for my car. We have enough data to make an educated decision. In case the solar production is enough to charge at 16 amps, which I can easily query, because I've done all of the math before, I know the energy available for charging, which is the delta between production and the demand of my house. If it's at or above 3680, which is 16 amps times 230 volts, I should be able to get started. And this is where at 10:35, which is roughly 7 minutes ago, I did turn it on. And by, again, just querying Home Assistant and telling him, please turn on this specific switch. On the other hand, in case there was not enough demand, which I simulated before this video, if the car is still charging, whereas there is less than 16 amps available, the algorithm will force car charge to stop in case the car is still charging, which is what happened at 10:34 right before I started to record this video. If you want to have the latest on the context data, click here. Otherwise, you've just seen how to implement car charging. Let's now tackle the most common smart charging scenario. No change to the physical setup, but in this case we have a more capable car charger whose charging power can be adjusted with the mobile application supplied by the car charger manufacturer. In my case, living in Europe, my car charger can be adjusted between 6 to 32 kilowatts. If you live in the US, yours could have a different range of charging because of the change of voltage. Please adjust the formula to match your setup. The base logic is identical to the fixed charging algorithm. The only difference is that at every cycle we must calculate the optimal number of amperes. This is how car chargers are to be configured. For example, if my solar panels at a given time of the day produce 4,000 watts, and my house needs 1000 watts at the same time, I have therefore 3000 watts to allocate to car charging, or 13 dot something amperes at 230 volts, which we will round down to 13 amperes and therefore configure the car charger amperes accordingly. Pause this video if you want to review the algorithm in greater details, else let's turn again to Node-RED and see how this could be once again implemented. We're now on the second option, pretty well the same thing, except that now have a smart car charger which can be configured from 6 to 32 amps, which is from roughly 1500 to 7000 watts of charge. I want to cap it at 16 amps because this is 40% roughly of my peak watt capacity generation. And as you can see, if you look at it from a high level, it is a tiny bit more complex on the right hand side, whereas on the left hand side it seems to be almost the same as the basic car charging. So I'm going to hit it manual refresh because I want to have the latest data, which is done. I have access to the flow data, which I just rebuilt. And we have roughly the same algorithm with a few exceptions. So I'm still getting the same data and a few modifications. I need to get the current charging number of amperes from my car charger, which again, I do simply by querying my wallbox car charger to get its current amperes. So currently it's charging at 16 amps, which is the new variable right here. I then do exactly the same math. The difference is that now I've modified the algorithms. I first ask myself, is there enough sun? And in case there is not enough sun, and enough sun being that the available current for charging, which is total generation of electricity minus usage of the house, is above 6 amps, which is 1380, 6 amps times 230 volts where I live. And in case there is not enough energy and I'm still charging, as you can see, I go ahead and pause the car charging. As we can see here, we now have an algorithm that says that if I have more than 6 amps, I will set the best possible car charging, which is now in this case 4533 watts available divided by 230. It's going to be giving me 19 or something, but by doing some basic math with the floor function, I will just get rid of anything after comma and therefore get it down to an integer 19. So I can see that I'm deciding to, and I'm going to hard code it, to charge my car at 16 amps even though 19 would be available. And I'm going to be forcing this value, and if the car is still charging, all good. Otherwise, in case there is not enough watts, I will stop the car in case it's below my threshold. And now let's have a look at a setup which is entirely off-grid. This setup is rarely supported by car charger manufacturers. It actually is my home setup. The physical setup has changed. There is no more connection to the grid. And we now also have home batteries to provide electricity during the night. We must here add the context of the home batteries to the algorithm. If we just use the previous approach, the smart car charging would not be aware of the home batteries and charge the car batteries first. This would leave the homeowner exposed to a situation where the electric car batteries would be full and home batteries would be empty at night, which would force starting the backup diesel generator during the night, and that would not be very sustainable. Whilst the adjusted algorithm is not drastically different from the previous version, we have added the home batteries to the landscape. More precisely, this system will not charge the car if the home batteries are below 90%, thereby prioritizing charging the home batteries before the car. When the home batteries are between 90% and 97%, I use all available current to charge the car up to the max amperes your home can support. And finally, if the home batteries are 98% full or higher, I just charge the maximum amperes your home can support. A few caveats. I've personally set the max power of my home can support to 40% of my home peak watt specification. This might sound conservative, but a few clouds passing at the same time a pizza is heated through an oven at home, and you might go drastically beyond the capacity of your home in a second. Make sure you test various scenarios for cloudy and non-cloudy skies. Let's have a final look at Node-RED to see what my production home setup looks like. So this is now the totally off-grid smart car charging. As you can see, it got a bit more complicated. Just restarted it, by the way. So let me refresh the flows. It's roughly the same algorithm with a bit of a different layout. I'm going to make these basic decisions on the left, which is, is the car plugged in, is it daylight, and so on and so forth. And then I get all of the data, and this time I also get the details of my batteries, my home system batteries. So this is what I know, if they're 100%, not 100%, and so on, which is a key decision I will need. So it's roughly the same logic with only one or two exceptions. And the first one is after getting all of the data, I will be forcing a throttling decisions. In case you're not connected to the grid, what will happen if you have completely fully charged batteries or almost fully charged batteries? The home battery charger will be throttling, meaning it will going to be reducing the production of electricity. And if this is the case, which is typically, in my case, if the batteries, home batteries at 98% or higher, I'm going to force the batteries to start charging at 16 amps, unless of course if there is not enough sun, which is because it's below 98%. That will force the equation in case the reduction of electricity production is due only to the fact that batteries have reached their full potential. Then I will make a decision. In case the batteries are at above 98%, I'm going to charge at 16 amps. I have some race conditions, which mean that you can see, for example, I'm going to wait 2 minutes in case I've set my wall box to 16 amps, manually the top charger speed I want. It might take a few seconds for the car charger to be configured, and up to 1 minute for the next refresh cycle from Big Timer. In order to mitigate that, I'm putting a 2 minutes wait before I'm asking the same questions again. Otherwise, I would be trying to resume charging multiple times, and that would likely fail. If the batteries are in between 90 and 98%, I will be doing the famous calculation. If it's below 90%, I'm going to pause. And as you can see, this is just what happened. At 10:54, which is 2 minutes ago, the algorithm decided to pause the car charging. Why? It's pretty simple. Home battery 61%. So the car charging is not paused, and batteries will stay at 11% for the car until such time that the home batteries will go to 90%. So if I go back to Node-RED, this is exactly the behavior I wanted. Meaning that I wanted to prioritize charging my batteries of my home before I focus on charging my car. So once the batteries exceed 90% charging, out of 5,600, my house is only using 900, and therefore above 4,000 watts will be going to charge the batteries of my house. So all of it will resume at 90%. When the batteries of my home are in between 90 and 98%, the algorithm will start again and will again do what I've explained in the previous video on smart car charging for configurable car charger. It's going to be adjusting the car charging to the electricity available. You will see a few things such as try again in 3 minutes, try again in 2 minutes. Well, those are meant primarily, 2 minutes is the race conditions, which I've explained previously, and try again 3 minutes is cloud. It's annoying to have a cloud passing above your house and suddenly you see that the car charging stops because the cloud was passing by. Even though with my battery system I could easily for 2 or 3 minutes take the electricity from my batteries before the cloud goes away, full sun is produced again, and I'm back in business. So all in all, this is how I have a production system which allows me to be charging my car with only electricity in an entirely off-grid smart charging. As we have seen in this video, once you have access to the right data, you can optimize energy usage and customize charging the way you want. For example, you have more than one electric vehicle? No problem, trigger them as you want. You'd like to charge one vehicle more than the other because it will do longer distances? No problem. Set the charging amperes accordingly. You want to manage a fleet of cars and prioritize charging all cars whose drivers have a business meeting or a delivery. Also easy with the calendar integration and Google Maps integration. Charge until the distance reporting by Google Maps is exceeded in the car range telemetry. And so on. I mean, the possibilities are only limited by your imagination. I'd love to hear from you now and learn from you. What use case were you able to implement and which personal or business problems were you able to overcome? As always, if you like this video, please give it a like. And if you want to learn more about sustainable journey, consider subscribing to the channel. Thank you, and I will see you in the next video.